Hello and welcome to Physical Security Architecture. Today we will visualize how to map um, the field of view of a security camera. Today we will discuss how to map the field of view of a security camera in an architectural layout. So we're going to take this so basically we're going to take Hikvision's fixed camera. This is a fixed lens camera with a focal length of 4 mm. So as we discussed that fixed lens cameras cannot change their focal length, and in varifocal cameras we can change the focal length. So basically in this camera the angular field of view will not change. There are some other options for lenses, and each lens has its own field of view, but for 4 mm lens the angular field of view is 73.1 degrees. So if this is the camera, then the angular field of view is supposed to be 73.1 degrees. This is how you can map the field of view of a CCTV camera in an architectural layout. So as they have given the horizontal field of view, but in the data sheet the vertical field of view, which is supposed to be on this side, is not mentioned. So what we have done is we have taken this length, and which is 148 feet, and what we've done is we've extruded this surface till 111.47 feet. Now why is that? Because the aspect ratio that it gives is supposed to be according to its resolution. The resolution is this 1280 into 960. So we can see that this is the aspect ratio, and we can extrude this surface to an amount that this surface, the surface that I've just selected, is supposed to be in the same aspect ratio as the mentioned resolution. And we've also kept the object distance from the camera to 100 feet, as it mentions in this data sheet that the IR range is 100 feet. So it means that in night time this camera will give you a clarity of a view till 100 feet from where the camera is placed. So this is how you can map, how you can design the 3D space of a security camera. Now let's have a look at another camera which belongs to Pelco. So as you can see that this camera is autofocus motorized remote zoom lens. So it's a very focal camera, which can change its focal length. And let's take this one, IBP231. Now in this datasheet they have given us the focal length which can change. It starts from 2.8 mm and it can go to 12 mm, and it has also been mentioned, and they have also mentioned the field of view, the horizontal field of view and the vertical field of view, the angular field of view, and the diagonal field of view. And they've also mentioned the horizontal field of view, vertical field of view, diagonal field of view corresponding to these focal lengths. So now let's see how does this camera map, how does this camera capture an image corresponding to the focal length 12 mm. So when it's 12 mm, the horizontal field of view will be 34 degrees and the vertical field of view will be 19 degrees. So here we are. Okay, so this yellow region is that region which shows that angular field of view which corresponds to 12 mm focal length. Therefore it is 34 degrees. And if we have to see the vertical field of view, then this angle is 19 degrees. So this is how it is supposed to be. On the top, from the top, it is supposed to be 34 degrees, and from the side the vertical field of view is supposed to be 19 degrees. Now for 2.8 mm focal length, the horizontal field of view will be 101 degrees, and you can see that as the focal length decreases, the horizontal field of view increases, so it can capture more area. And as for the vertical field of view, you can see that it is supposed to be 53 degrees. So you can see that this angle is 53 degrees. So this is how this 3D space should look like. What we can do is we can also okay, so not only does changing the focal length affect the field of view, but it helps you to focus on objects which are closer and which are far from the lens.